Okay, Bismillah ar-Rahman ar-Rahim. Now we'll finish with this one. Now we'll continue. Mainly we have some questions and then questions from the book. Hopefully we can do it quickly. Hopefully this time it's working. Yeah. Yeah, this is, I think, is related to the sigma notation, but let me do it. Limit n goes to infinity. I have 5 over n. Summation I equal 1 to n. Open the square. That will be 1. Plus 2i over n times 2, which is 4i over n, plus 4i squared over n squared. So that I want the limit as n goes to infinity, 5 over n times. Yeah, this one will be summation I equal 1 to n of 1 plus 4 over n summation I equal 1 to n of I. 4 over n does not have I, so I can take it out. I can take it, outside. 4 over n square, summation of I square, I equal 1 to n, the same idea. So that will be limit, n goes to infinity, 5 over n, times what? This summation is n, plus 4 over n, times what? n plus 1 over 2. Okay, plus 4 over n square of what? Of this one is what? n plus 1 to n plus 1 over 6. Okay, so I want to find the limit. N goes to infinity of 5 plus 4 n plus 1. N will be cancelled with n. This is 2 over 1. That's no need for. That will be 2 over n. Yeah, don't forget over n. Not 2. Sorry, that will be 10. Okay, 5 times 2. 10 n plus 1. Okay, here n will go with 1 n. And you have the remaining plus 20 n plus 1 times 2 n plus 1 over 6 n squared. Okay, we can find the limit easily. This is 5. This is same degree, so 10 over 1, which is plus 10. Here we have what same degree also. This is a square and this is square. So the coefficient, the leading coefficient in the numerator is what? 40 over 6. 40 over 6. Yeah, let me write it. 40 over 6. That will be what? 15 plus by 2. This is 20 over 3. So that give me what? 45 plus 20, 65 over 3, which is this one. Yeah, I think it's an easy one. There is the region bounded by the graph of this and the x-axis and the vertical lines given. Choose CI to be the right endpoint. Just a matter of calculation now. For any n subintervals. I use n subintervals. Since I wanted to find the area, it's not an approximation. So I need the limit. So the area, yeah, we'll do delta x will be b minus a over n. That will be 1 over n. Xi, right endpoint, will be a plus I delta x. That will be 1 plus I over n. Plus I over n. خلاص. So this is my f of x. F of xi will be what? Will be 4 minus 1 plus I over n square. That will be 4 minus 1 minus 2i over n. Yeah, let us do it. It can be easy. It will be 4 minus 1 plus 2i over n plus I square over n square. That give me what? 3 minus 2i over n minus I square over n square. خلاص. So what will be my area? Will be limit n goes to infinity, summation I equal 1 to n, f of xi delta x. That will be limit n goes to infinity. Notice the way he wrote it with the summation. Delta x, I can take it out. That will be 1 over n. That will be 1 over n. Okay. Summation I equal 1 to n. From where this 3 over it comes. Yeah, he took the 3 out. This is 3. Minus summation I equal 1 to n of 2 over n, 2i over n, minus summation I equal 1 to n of I square over n square. Okay, this is a constant. I can take it outside. That will be limit n goes to infinity. This 3 can be taken out. 3 over n summation I equal 1 to n of 1. Now 1 over n, I take 2 over n outside. That will be minus 2 over n square summation I equal 1 to n of I. I want to write it the same way he wrote it, okay? Minus, I took 1 over n square outside. That will be 1 over n cubed summation I equal 1 to n of I square. The limit of this. And this is the answer. Okay. Now let me go to the questions from the book. Yeah, I'm starting with the 21 because the rest I did it in this sigma notation recording. Yeah, I think these are easy ones, but maybe calculation things you need to be careful. Oh, I need to use left and endpoints for a given number of rectangles. Find two operations between the graph function and the x-axis. Okay. Yeah. Yeah, I need to deal with this. Let me bear it in the right way. Okay, let me go back to the file and try to do these things. Hopefully the space will be enough. I want both L and R. Okay, so first one, 29. What will be my delta x? This is A, this is B, this is N. B minus A over N. That will be 2 minus 0 over 4. That will be half. Okay, this is my delta x. Yeah, for the lower, for the L, we use the left. This is for, call it L. And this is, we call it R. Okay, so L, yeah, for L4, let's say use 4 rectangles. Yeah, let me start with the R, I think. Yeah, better. For Rn, xi will be A plus I delta x, which is what? 0 plus I over 2, which is I over 2. Okay. Or you can do it like this. We're starting with 0, add half, that will be half. Add another half, that will be 1. Add another half, 3 over 2. Add a third half, that will be 2. Yeah, I think this will be better. So split it now. For Rn, I want the right endpoint, right endpoint, right endpoint, right endpoint. Okay, so R4 will be what? Delta X, f of half, plus f of 1, plus f of 3 over 2, plus f of 2. And that give me what? Delta X, which is half, f of half, what is the function? This is the function. F of half, it will be what? 6. F of 1, it will be 7. F of 3 over 2, that will be 6 plus 5, is it? F of half, it will be 6. F of 1, it will be 7. F of 3 over 2, that will be 6 plus 5, that will be 11. F of 2, that will be, is it? No, this is 8. What is this? 11. It is 3 plus 5, which is 8. Huh? F of 2 is 9. So that give me what? 6 plus 9, 15. 15. So 30 over 2, which is 15. L4, it will be delta X. Now I choose the left endpoints. Huh? Left endpoints, left endpoints, left endpoints, left endpoints. F of 0 plus f of half plus f of 1 plus f of 3 over 2. That give me what? Half times what? F of 0, f of 0, it will be 5 plus 6 plus 7 plus 8. That will be 26 over 12 over 2, which is 30. That will be L4. That will be. So my area will be between L4 and R4. Between 30 and 15, something like that. Okay. Second function, which is this one. Calculation. It's a matter of calculation. Yeah. 31. Delta X will be what? This is A and this is B. It will be 5 minus 2 over 6. Where I have n equals 6. That give me what? 3 over 6, which is half. So if I want to split it, yeah, I need 6 rectangles. Who cares? Yeah. This is, I start with 2, add half. That will be 5 over 2. Add half. That will be 3. 7 over 2. That will be 4. Yeah. 9 over 2. That will be 5. Okay. For Rn, I'll choose the right endpoint. For N, I use the left endpoint. So I need now R6. I use this. I have delta X, f of 5 over 2, plus f of 3. No. Yeah, I need the right endpoint. Yes. Right. Yeah, plus f of 7 over 2, plus f of 4, plus f of 9 over 2, plus f of 5. Yeah, if we do the calculation, I don't think I will waste my time. It will be 74.5. L6, I'll use now the left endpoint. So it will be f of 2 plus f of 5 over 2 plus f of 3 plus f of 7 over 2 plus f of 4 plus f of 9 over 2. If we do the calculation, that will be 55. Okay, now let me do 34. Let me do 34. Yeah. Mm-hmm. 34. I have f of x equals sine x. And they want what? 0 to pi. And they want 6 rectangles. So this is n, this is a, this is b. Delta x will be pi minus 0 over 6, that will be pi over 6. So actually you're doing this. This is 0, you add pi over 6. You add another pi over 6, that will give you what? Pi over 2. Is it? No. Pi over 6, it will be pi over 3. Then pi over 2. 4 pi over 6, which is 2 pi over 3. 5 pi over 6. And then 6 pi over 6, which is 6, which is pi. Huh? This is 2 pi over 6. This is 3 pi over 6, 4 pi over 6, and so on. Okay. So for R6, what will be the area approximately? All of this approximation is not the exact area. The R4, I need to find the R4 is this, but the area will be approximately R6, which is delta X times what? Right endpoint, f of pi over 6 plus f of pi over 3 plus f of pi over 2 plus f of 2 pi over 3 plus f of pi over 6 plus f of pi. That will be what? Pi over 6. Yeah, you can do the calculation now. Sine f of pi over 6, that will be half plus square root 3 over 2. Yeah. And this one will be f of pi over 2, which is 1. 2 pi over 3, which is another square root 3 over 2. This is plus half plus 0. Okay. This is not there. This is R6. Yeah, the function is going up and down. The function going up and down. Okay. If you do L6, that will be what? It will be delta X f of it is f of left endpoints now, f of 0 plus f of pi over 6 plus f of pi over 3 plus f of pi over 2 plus f2 pi over 3 plus f of pi over 6. And that give me what? Pi over 6 times what? F of 0, 0 plus half plus a square root 3 over 2 plus 1 plus square root 3 over 2 plus half. You notice this is same as this. So L6 equal R6. Why is that? Because note إنه if because of the symmetry, because this one is going up and now there's a symmetric. So if I use the left endpoints, sometime in this case, since it's increasing, the left endpoints will give me lower and this is give me upper, but it will be the same. So they will cancel each other. So L6 equal R6. Okay. They're using upper and lower sum. We want to use now upper and lower sum. I want to find the area. Part 5, bound the area of the shaded area is approximating the upper and lower sum. I want to find the area. Use the rectangles of width 1. You told me the width is 1. So that make it easier for me. So now, the upper, now the function is increasing. The function is increasing. So the upper will be what? Okay, the function is increasing. The upper will be left a right endpoint, upper in this case. I'll use right end. Okay. Since if you take this rectangle, The f at 1 is 0, and f at 0, if you're using 0 to 5. It's from 0 to 5. So if I use f at 0, how many rectangles? Up to 4. So I have it from 0 to 4. F at 0 will be 1, and f at 1 will be 3. Yes, yeah, let me do it like this. So I have 0, and I have the width is 1. So f at 0 will be 1. F of 1 will be 3. F at 2 will be 4. F at 3 can make it 4.5, 9/2. And f at 4 will be 5. So I want to use the upper. In this interval, choose this. In this interval, choose this. I'll choose the bigger one since the function is increasing. If I want to use the upper, right? So let me call it capital S. That will be delta x times f of 1 plus f of 2 plus f of 3 plus f of 4. Delta x is 1, خلاص. F of 1, that will give me 3 plus 4 plus 9/2 plus 5, which is 12, which is 24 plus 9, that will be 33/2. Okay, lower. Well, it's small s. That will be delta x. Now we choose f at 0 plus f at 1 plus f at 2 plus f at 3. This is 1. That give me what? 1 plus 3 plus 4 plus 9/2. If we do the calculation, that give me 25/2, which is 16 plus 9/2. 16/2 plus 9/2. So very clear, my area is between small s and capital S. This one, be careful. Yeah, I use now same thing. This is 1, 2, 3, 4, and this is 5. I have f at 1 is what? Is 4. F at 2 is what? Is 5. It's going up and down, huh? F at 3 will be what? 4. F at 4 is 2. F at 5 is 0. Okay. Now we need to be careful. Yeah. The upper sum, capital S, will be delta x. Be careful. In this one, I will choose f at 2 because it's bigger. Huh? I'll take the bigger one. So in this interval, I take f at 2. In this interval, I'll take f at 2 also. Okay, in this interval, I take f at 2. In this interval, I will take f at 3. In this interval, I will take f at 4. That should be clear, huh? I took the bigger one, huh? F at 1, 4, and 5. I'll take f of 2. 5 and 4. I'll take f of 2 also. Huh? Let's take this one. Since it's going increasing and decreasing. خلاص? So that will be what? Delta x is 1. F of 2, 5. That will be 5 plus 5 plus 4 plus 2, which is 16. This is upper. Huh? Now it comes to the lower. I'll take small s, delta x. Be careful now. F of 1, f of 2, I'll take f of 1, the smallest. Here I take f at 3. Between 4, I take f at 4. Then take f at 5, the smallest, huh? I take the smallest. That will be 1, f of 1 come, 4, f of 3, another 4, and that will be 2 plus 0. That give me 10. So this is the lower. So my area is between 10 and 16. Okay. No need for this space. Okay. Now square root of x. Yeah, this is easy, huh? Because either it's going up or it's going down. Huh? But that one was tricky a little bit, especially this one, because this is increasing and decreasing. Okay. Now upper and lower sum for this region. Okay. Let me do it quickly. Yeah, 37. Okay. If equal width, and use upper and lower sum to approximate the area of the region bounded by this. The given number of subintervals. Yeah. How many subintervals they have? 1, 2, 3, 4. So my n is 4, and it's from 0 to 1. Okay. So my delta x will be 1 minus 0 over 4. So it will be 1 over 4. Okay, I think it's good to put it this way. That will be 0, 1 over 4, half, 3 over 4, then 1. Okay, upper. Since the function is increasing, so the upper will take the right endpoint. Increasing, خلاص, right endpoint. Huh? Upper, huh? Capital S يصير delta x. Yeah, if you want, I can do something like this. Here, if at 0, to make it clear, if at 1 over 4, that will be half, huh? Square root of x. This f of half, that will be 1 over square root of 2. This is f of 3 over 4, square root 3 over 2. F of 1, that will be 1. Okay. The upper, very clear. The function is increasing. Huh? The function is sort of take f of this, 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 this. This is will be upper. So it will be delta x, f of 1 over 4, plus f of half, plus f of 3 over 4, plus f of 1. That will give me what? 1 over 4. Huh? Yeah, 1 over 4, half, plus 1 over square root of 2, plus square root 3 over 2, or this to make it square root 2 over 2. Square root 2 over 2, plus 1. Yeah, I think I will leave it like this. Now, if you want to take the smaller, yeah, this one you can write it what? You can write it. This is, you can make it 2 over 2. So it will be over 8, huh? 3 plus the square root of 2 plus square root of 3. Yeah, can leave it like this. Okay. The lower, huh? Let me do the lower here. Now continuation about 37, huh? Lower. I will use what? It will be delta x. Let me call it capital S. Small s. This is called it small s. So it will be delta x times what? The lower, I will take left endpoint here because the function is increasing. So it will be f at 0, the smallest, f at 1 over 4, plus f at half, plus f of 3 over 4. That give me what? 1 over 4 times what? F at 0, 0, plus half, plus square root 2 over 2, plus square root 3 over 2. So it's what? 1 plus the square root of 2 plus the square root of 3 all over 8. Yes, 38. How many we have? 1, 2, 3, 4. And it's from 0 to 2. Say A equals 0 and B equal 2 and N equal 4. Okay, so I want to do the same thing, upper and lower. Okay, so my area is between them, huh? Yeah. Yeah. Okay. So delta x will be what? 2 minus 0 over 4, which is half. So I'm starting with 0, add half. That will be half. That will be 1. That will be 3 over 2. That will be 2. Very clearly, the function is decreasing. So the upper, I'll take the left endpoint, upper. You can check it, F at 0 will be what? What's the function? It will be 4. F at half, it will be 4 is minus half. Yeah, not easy to check. F at 1, but from the graph is very clear, Yeah, no need to waste time. From the graph, the upper, since the function is decreasing, if I want to take the upper interval, I'll take the left endpoint. Since the function is decreasing function. I think this idea should be clear. So call it capital S will be what? Delta x times f at 0 plus f at half plus f at 1 plus f at 3 over 2. That give me what? Half. F at 0 is 1. Not 1, 4. 4 e to the power 0, 4. Plus 4. Yeah. Plus 4 e to the power minus half. Plus 4 is minus 1. Plus 4 is minus 3 over 2. Yeah, leave it like this. I can take 4 outside, so it will be 2 times this. You can do the calculation. I will leave it for you. Lower, I will take right endpoint. Why? Because it's a decreasing function. Small s will be delta x times f of half plus f of 1 plus f of 3 over 2 plus f of 2. Yeah, I will leave it for you. Yeah, I think it's very clear. No need for this space. Again, upper and lower sum for this. In exercise, find the upper and lower sum for the region bounded by the graph of this. He wanted to find it in terms of, leave your answer in terms of n. I want it to be in terms of n. So I do the calculation in terms of n. Okay, let me check the function easily. The function is what? This is minus 3. Function will do something like this. This is 3. So I'm thinking about this from 0 to 2. Only to 2 here. This is what I'm looking for. Okay, so the function is decreasing. Very clear, it's decreasing. Decreasing. So if you want to take the upper, I'll take the left endpoint. Lower, I take the right endpoint. Upper, since the function is decreasing on the way. Upper, left, lower, right. Let me do the lower. For example, delta x in terms of n, it will be what? From 0 to 2. It will be 2 minus 0 over n. That will be 2 over n. Okay. And lower. Yeah, let me find xi. Xi is 0 plus I delta x. That will be 2i over n. This is for right, which is the lower. For the lower. Okay. So for the lower in terms of n, no need to do the limit, just the summation. Okay. So let me call it s, small s. We want to find the lower. S at n will be what? Will be summation I equal 1 to n f of xi times delta x, which is what? Which is, be careful now. I need to find f of 2i minus f of 2i over n. That will be, delta x is 2 over n. I can take it out. Who cares? I equal 1 to n because it has no I. F of this, which is 9 minus 2i over n whole square. Okay, that give me what? 2 over n summation I equal 1 to n of 9 minus summation I equal 1 to n of 4 over n square I square. That give me what? 2 over n. That will be 9n. Okay. Is it? Yeah, let me check. Maybe there is some calculation there. Okay. Minus 4 over n square summation of I square. Summation of I square is what? n plus 1 to n plus 1 over 6. Okay. Yeah, I think I need to do the calculation. Yeah, let me continue here. That will be 2 over n times 9n minus. This is 2. This is 3. Okay. Yeah. 2 over n square times what? This one is 2n square plus 3n plus 1 times n. So plus 2n cubed, huh? 2n cubed plus 3n square plus n over yeah, times this, huh? Over 3. This is times this. Okay. A method of calculation now. 2 over n, 9n minus 4n, huh? That will be that is what? 4n cubed over 3n square. That will be 4n over 3. Okay. Yeah. That will be 4n cubed over n square. That will okay. Plus or minus 2. Minus 2. Okay. N square cancel with n square. 3 with 3. So it's minus 2. Minus 2 over 3n. So that give me what? 18 minus n with n, 8 over 3, minus 8 over 3, minus 4 over n, minus 4 over 3n square. Okay, and that will be what? 18 is what? 54 minus 8, that give me 46. So it will be 46 over 3, this, minus 4 over n, minus 4 over 3n square. Now we'll come to the, this is the upper. Yeah, which is a little bit, yeah, I have a space, okay. For the upper, now I need xi minus 1, since I need now the left endpoint. That give me what? 0 plus I minus 1 delta x, which is 2 I minus 1 over n. Okay, so that's, I have capital S of n, that will be summation I equal 1 to n f of xi minus 1 delta x. So I have 2 over n outside. Yeah, be careful now. Summation I equal 1 to n. Yeah, 9 minus 4 over n square times I minus 1 square. That will be 2 over n times what? Yeah, summation I equal 1 to n of 9 minus. Yeah, this is open it. This is what? I square minus 2i plus 1. Just to save time. That will be 4 over n square times I square. Minus times minus, that will make it plus 8. Over n square times I minus 4 over n square. All of this under the summation. So that give me what? 2 over n. This is 9n. This is minus 4. Yeah, it's a matter of calculation. n plus 1 to n plus 1 over 6 plus 8 over n square. That will be n plus 1 over 2. And this is minus 4 over n square times n, because it has no I. If we do the calculations, you get this. I will leave it for you. You get what? Yeah, the same answer, almost the same answer, but instead of minus, plus. 46 over 3 plus 4 over n plus 4 over 3 n square. Matter of calculation here. You can do. And this is capital S of n, the upper. Okay. Find the area by the limit definition. Yeah. 47. In exercises, use the limit process to find the area of the region bounded by the graph of the function. The exercise, I want just to find the area. So do 47. The limit, the limit. I will do right endpoint to make it easier. Delta x. This is A. This is B. And choose n. N subintervals. N subintervals. N subintervals. Delta x will be 1 minus 0 over n, which is 1 over n. And they have xi will be 0 plus I delta x, which is I over n. So the area is 47. The area will be the limit. N goes to infinity. Summation I equal 1 to n. F of I over n, which is minus 4 I over n plus 5. Don't forget, I have delta x here. Now, do not depend on I can take it outside. So that gives me limit n goes to infinity of 1 over n of this. This will be what? Minus 4 over n summation I equal 1 to n of I plus summation I equal 1 to n of 5. That gives me limit n goes to infinity of what? 1 over n times what? I have minus 4 over n. This is n plus 1 over 2. Okay. Plus 5n. That as a limit n goes to infinity. I have what? This is 2. Cancelled. This is 1. I have minus 2n minus 2 over n plus 5 as a limit, the same degree. That will be minus 2 plus 5, which is 3. That will be okay. Let me do this one. Same thing in subintervals. What will be delta x? Will be 1 minus 1 over n, which is 2 over n. xi will be -1 plus I delta x. So it's -1 plus 2I over n. Yeah, I need to do the square and the cubed. F of xi will be -1 plus 2 over I square minus -1 plus 2 over n cubed. Yeah, do the calculations. And the area, I will leave it, limit n goes to infinity of this summation. I equal 1 to n, f of xi, delta x. You know delta x, you can take it out. This is half I, sorry, this is 2. I cube, you do the formulas, you get the answer. And the answer is, yeah, the answer is 2 over 3. 2 over 3. Okay. Finding area by the limit definition, but now in terms of y. Yeah, the same thing, huh? Instead of going, yeah, for the first one is this one, huh? And I'm doing the, yeah, I'm going from 0 to 5. I'm going from 0 to 5, huh? Yeah, going this way. This is the function. Okay, so I'm doing it from 0 to 5. I'm doing the rectangles horizontal, not vertical. Okay, so do the calculations. 59. My delta y now, it will be 5 minus 0 over n. You want to use the limit, so I treat it in terms of n, 5 over n. And my area will be the limit, n goes to infinity. I equal 1 to n. Yeah, that will be yi. Yi will be a plus I delta y. A0, that will be 5I over n. Huh? The rectangles, I'm going this way, huh? Okay. That will be f of yi delta y. That give me what? This is 59, huh? That give me limit n goes to infinity. Yeah, of this summation, which is delta y 5 over n times summation I equal 1 to n 5I over n square, which is limit n goes to infinity 5 over n of summation I equal 1 to n 25 over n square I square. This I can take it out. That will be limit n goes to infinity 125 over n cubed, summation of I square, which is n plus 1 to n plus 1 over 6. So I have cubed over cubed. That give me what? 125 times 2, the leading coefficient, over 6. That will be 3. That will be 1. So it's 125 over 3. Yeah. 60. The same idea. I will just do the starting point. Delta y will be 3 minus 2 over n, which is 1 over n. Yi will be a plus I delta y, which is 2 plus I over n. My f of yi will be 3 times this minus this square. Yeah, it's a matter of calculation. You put it in the sum. The area will be the limit n goes to infinity, summation I equal 1 to n, f of yi delta y. I think you can do matter of calculation, and the answer is 7 over 6. That will be the answer. Use the midpoint. Now, if you wanted to use what? The midpoint. Yeah. We'll do some of them. Use the midpoint to approximate with n equal 4. I want to do approximation. It's not the exact, huh? Okay. So I have, this is from 0 to 2. Yeah, and n equal 4. So delta x will be 2 minus 0 over 4, which is half. So 0, I add half. Half, 1, 3 over 2. So I have 4 rectangles now. This is 63. Okay. So it will be now my calculation. Yeah, the midpoint, huh? Here I have what? 1 over 4. Here I have what? 3 over 4. Here I have what? 5 over 4. Here I have what? 7 over 4. Okay. So the area will be approximately summation. Okay. I equal 1 to 4. F of, no, let me do it this way. Since it's 4, I have half delta x times f of 1 over 4 plus f of 3 over 4 plus f of 5 over 4 plus f of 7 over 4. Delta x is half. Yeah, in a substitute here. Huh? 1 over 16 plus 3 plus 9 over 16 plus 3 plus 25 over 16 plus 3 plus 49 over 16 plus 3. That give me what? Half. 3, 3, 3. That will be 12 plus 10, 25 plus 94 plus 49 is what? That will be 74, 84. 84 over 16. Okay, over 4, that will be 21. Over 4, that will be 4. So that will be half is 48 plus 31, that will be half times 69 over 4. So the answer is 69 over 8. Yeah, I think it's easy to do. 65. Yeah. What will be delta x? How many rectangles? I have 4. Delta x will be pi over 4 minus 0 over 4. And that will be pi over 16. Pi over 16. So I have 0. I have pi over 16. Add pi over 16. You have pi over 8. Add pi over 16. You have 3 pi over 16. And then you have pi over 4, which is 4 pi over 16. You need the mid. Pi over 32. This one, 2 by 3 pi over 32. Here, 3 plus 2, 5 pi over 32. Here I have 7 pi over 32. Yeah, so your area will be approximately delta x, which is pi over 16. I choose the right endpoint, huh? Tan. The mid, actually. Tan pi over 32 plus tan 3 pi over 32 plus tan 5 pi over 32 plus tan 7 pi over 32, which is kind of approximate. Yeah, I leave it for you. Yeah, you can you can leave it like this, or you need the calculator. Okay. Now this one, 67. Yeah, delta x Yeah, this one would be easy. 5 minus 1 over 4, which is 1. خلاص. So this is 1, 2, 3, 4, 5. So I need 3 over 2, huh? 5 over 2, the mid, 7 over 2, 9 over 2. Okay. Now it in equal 4. Okay. So this is 1, so the area approximately, yeah, I will leave it like this. Delta x times summation I equal times f of 3 over 2 plus f of 5 over 2 plus f of 7 over 2 plus f of 9 over 2, which is what? Len 3 over 2 plus len 5 over 2 plus len 7 over 2 plus len 9 over 2. Yeah, you can simplify it the way you like. Okay. Now let me do more. Determine which value best approximate the area of the region bounded by the graph of this and the graph of this. Yeah. Determine which value best approximate the area of the region bounded 69. Huh? What is the function? A function 4 minus x squared. So this is the graph of the function, which is something like this. You want it from where to where? From 0 to 2. So I care only about this, from 0 to 2. 2 means here. I'm dealing from 0 to 2. I want the one which is can be used to approximate the area. What is best? Approximate the area of the region bounded by this and the exercise over the interval. Make your selection without doing the calculation. Okay. Okay. If you notice, this is 4. So my area will be less than 2 times 4. And should be positive. So this will be the best area. Is 6. This is more. This is too small. This is more. And this is negative, cannot be happen here. So the best will be 6. I think this will be easy. Okay. Approximating a function. Approximation. A function is continuous, non-negative, concave up, and decreasing. That's the most important thing. Decreasing. Okay. On the interval 0 to a. Interval 0 to a. 70. The function is doing something like this. It's concave down. It's decreasing from 0 to a. Does using the right endpoint of the subinterval produce an overestimate or an underestimate? Right endpoint. Decreasing means what? If you use the right endpoint, if you use the right endpoint, if you're using the right endpoint, so you are missing this. So you are getting underestimate. Your area will be less than, or your calculation using the right. Huh? The area given, because the function is decreasing. Huh? So there is something missing. The area, this will be less than the exact area. Because something is missing. Huh? Since you are using the right. Since the function is decreasing. You're using the left, then that will make it overestimate. That will make it overestimate. You notice the rectangles here are inscribed inside the area. Okay. mean, the area of these rectangles will be less than the exact area. So you have underestimate. So my estimation is less than the exact area. This is what I mean by underestimate. Okay. And I think, yeah, we have these two. Let me do it quickly. What are the left? The function is shown in the graph. Below is increasing. That's important, from 1 to 4 into 12 subintervals. You wanted 12 subintervals. Okay, what they want? What are the left? What are the left endpoint of the first and last subinterval? Left endpoint, huh? Let me do a left endpoint of the first one. Very clear. Between this and this, it will be 1. Last left endpoint, huh? And instead of 4, this is right. I'll take this. So that will be what? 4. What is delta x, huh? Delta x will be 4 minus 1 over 12, which is 1 over 4. So that will be 4 minus 1 over 4, which is 15 over 4, which is 4 minus delta x. This one will be 4 minus delta x. Okay, part B. What is the right? What are the first two subintervals? Right, first right interval. Okay, this is will be 1, and this is will be 1 plus delta x. This one will be 2 plus delta x. So the first one, right endpoint, huh? The first will be 1 plus delta x, which is 1 plus 1 over 4, which is 5 over 4. The second will be 1 plus 2 delta x, which is 1 plus half, which is 3 over 2. Okay. When using the right endpoint, do the rectangles lie above or below the graph? As the function is increasing, I'm doing the right endpoint, so I'm getting more than the graph. Huh? I'm getting the area will be more. Okay, so the rectangles will lie above. In this case, C lies above. Why? Above the graph, huh? Because I am using the right, since the function is increasing. What can you conclude about the heights of the rectangles when the function is constant in the given interval? Yeah, if it is a constant function, assume it's now it's a different question, not related to this graph. Huh? If the height is constant, huh? What can you conclude about the heights of the rectangles when the function is constant? Assume I have a constant function between A and B. So the height will be the same. So the height will be equal to that constant. The height will be equal to that constant. Either it is to the right or to the left. It will be the same. It will be the same value since it's the constant function. Assume this is k. Y equal k, constant function. Y equal to a value 10, 20, who cares? The height will be equal to that constant. Okay. These are the last two, true or false. The sum of the first n positive integers is n. This is the formula. I have 1 plus 2 plus 3 plus n. This is n plus 1 over 2. This is the formula, so this is true. If it's continuous and then negative, positive, then the limit of it is lower sum and upper sum both exist and they are equal. Continuous. I need just a continuity. And then negative. Then the limit of its lower sum and lower sum should be both exist and are equal. Just say no, this is the true. This is this is true. Yeah, I will stop here. So this is will finish 5.2. Hopefully I will try to do soon 5.3. Yeah, let me stop the recording. Yeah, thank you.